Hi guys, welcome to Vedant Education. Today I am going to solve a different problem on uniform plane wave from electromagnetic theory. I picked this question from a recent GATE paper. So, a uniform plane wave traveling in free space and having the electric field E is incident on a dielectric medium with a relative permittivity greater than 1 and relative permeability 1 as shown in the figure, and there is no reflected wave. So this is the schematic given here. The relative permittivity of the dielectric medium is. So in this question we have to find the relative permittivity of the dielectric medium, which is epsilon r. So let's just draw a schematic here. So I'm just drawing another schematic of the same thing which is given in the question. So this is a dielectric medium. So let's say, and this is a free space, let's say this is one and this is second medium, and let's say that the relative permittivity and the relative permeability of this dielectric medium is mu r and epsilon r, and we know that for free space the relative permittivity is epsilon naught and permeability is mu naught. Okay, so once we set up that, then we will draw the incident wave. So here is the wave which is incident on the dielectric medium. And now let's look at the given electromagnetic wave. So if you see here, the electromagnetic wave has components AX and AZ, and notice that there is no AY, and they have given the axes here. So here this is X and this is Z. So from this we can understand that E has component only in the XZ plane, which is our incident plane. So what you can infer from that, the first thing you have to infer from the given information in the question is that the given uniform plane wave, so let me write it as UPW, uniform plane wave, is parallel to plane of incidence. This thing is very important to identify. Once you know that, once you know this, it means that since the electric field, the given electric field, so let's just say the electric field of the uniform plane wave, okay, and since the electric field is parallel, which is, I mean, whatever direction it is, if it's parallel to the plane of incidence, then this can be called as a parallelly polarized uniform plane wave. So identify that given UPW is parallelly polarized. Now, once you know that it is parallelly polarized, it means it can undergo a Brewster, it has a Brewster's angle. So what is Brewster's angle? So Brewster's angle is a angle at which there is no reflected wave for a parallelly polarized electromagnetic wave. So if there is if the wave is incident at, let's say, theta I, and this theta I is equal to the Brewster's angle, which can be said as theta B, then at this point there is no reflected wave. Since the question mentions that there is no reflected wave, it means that this plane is hitting the hitting the dielectric medium at an incident angle of theta B, which is the Brewster's angle. So in that case, what we can write is theta I is equal to theta B, since this information is already given here. So let's say if it had a y component also, if the electric field has a y component also, that means this one of the component is in the out of the plane or inside the plane, and only that component will be reflected from this surface if it is incident at Brewster's angle. So at Brewster's angle, the perpendicularly polarized components are only reflected and the other components are not reflected. So this is quite important in electromagnetic theory, the concept of Brewster's angle, and there is all given formula for a Brewster's angle for two medium. So if you have two mediums, which is 1 and 2, then the tangent of the Brewster's angle is given by refractive index of the second medium divided by refractive index of the first medium. So this is a quite important formula which you have to remember during your studies, and it's quite useful to remember also because many of the problems become very quite easy once you know this. So now once we have established all of this, the solution is quite quick and easy. So let's just draw these components on the schematic. So what we have here is the magnitude of the electric field, which is root 2 ax. So let's say this is root 2 ax, and there is minus az. So since x is in positive direction and z, this is positive direction, minus z will be in this direction. So it's az. Now we know that the electromagnetic the electric field is like this, with the components root 2 ax and minus az, and now we know that this is also theta I from the incident angle here. So what we can do is to write the tangent of this angle, which is tan of theta I is equal to root 2 upon 1. Now we know that tan theta I is theta b in this particular example. So tan of theta b is equal to root 2 upon 1, which is also equal to from this formula that it is n2 upon n1, and we know that the refractive index is square root of the permittivity. So we have epsilon r and divided by epsilon naught. So let's say this is epsilon r2 and this is r1. Okay. Now what we can see from this example is that we know the free space, we know the epsilon permittivity of the free space, and we know that the dielectric medium has, if let's say if it's epsilon r1, then it's epsilon r and epsilon naught. So from this we can figure out that epsilon r, which is the permittivity of the dielectric medium, is just 2. So once you solve this, once you identify that it's Brewster angle, it's pretty quick. So thanks for watching. Please subscribe to our channel for more updates on problems and solutions. Thanks.